Well, hello, everybody. Welcome to KBE Insider, and with our fancy new graphic. It's always nice to have a new intro clip just to make our lives more entertaining. We also got some cool new swag. I got the sweatshirt going, so we're always happy about swag. Let's see. I have a couple of new things today. So first and foremost, I'd like to introduce my co-host for today, who is Josh Wood. And, so we have a rule on the co-hosts along with me is that they must be named Josh. So even if it's somebody else, we're just going to call them Josh anyway. That way it's easier for me.
As I said when we were leading up to this, Landon, any Josh will do, really.
Exactly. So a little bit about the show. So Josh, do you want to introduce yourself real quick, and then I'll talk about the show a little bit?
Sure. Hi, everybody. I'm Josh Wood. I'm a developer advocate at Red Hat, principally focusing on OpenShift and especially operators as an extension to the Kubernetes API and OpenShift in a way of delivering features that we add atop the Kubernetes core in OpenShift.
Awesome. Cool. So the reason we do this show is to try to give you an inside look into what's going on in Kubernetes land, and in particular, like the idea being that if you kind of talk to, let's say, the lead engineers or the engineers who are actually doing the work, that you'll get a much better insight of where Kubernetes is going in the future, rather than the hopes and prayers of a product manager, or a press release. So that way, because it's open source, right? There is a lot of contribution that's done based on the engineers' recommendations, and sometimes that's well reflected in the press releases, and sometimes it's not. So we think it's a good idea to talk to the people who are actually doing the work, and we hope you do too. And so feel free to put questions in the chat, and or if you have any comments or whatever, we are always happy to have more engagement, as it were. So definitely let us know. But today's show, we are going to focus a little bit on virtualization. And so we have two guests, and the reason is because virtualization seems like something that isn't normally a part of Kubernetes, being a container orchestration platform. And I think what we're starting to see is that it's more than that, right? It's that it's an orchestration platform for lots and lots of different things. If you go back to like our first episode, you can see us talking to Clayton Coleman about how using it in general as a control plane, and it's kind of actually come up a number of times throughout our interviews. So we think there's a lot more going on there. So we invited two guests. One is David Vossel. I hope I said that right. Who's from the KubeVirt team, and the other one is Bandan, who works on KVM, or the Kernel Virtualization Manager. Is that right? I was like, I don't remember what the Virtual Machine. Duh. Yeah. I was like, I can't remember what the expansion is. And hopefully we can talk a little bit about virtualization and how it relates to Kubernetes. Let's start with David. Do you want to introduce yourself? I always say it's very difficult to remember or find out or discover or have any consistency to what titles and roles are within Red Hat. So I find it's much safer to let people introduce themselves.
Yeah, sure. I'm David Vossel. I'm an engineer at Red Hat. I'm contributing to the KubeVirt open source project, and it's kind of evolved into an ecosystem. So I'm kind of contributing to the KubeVirt ecosystem at this point. I was involved with the KubeVirt project early on, got the opportunity to design a lot of the way that it operates today. So I'm coming at this from a KubeVirt perspective.
Gotcha. Cool. All right, Bandan, how about you?
Hi, my name is Bandan. I work in virtualization. As Langdon said, I work mostly on KVM, which is the kernel-based, virtualization module in the Linux kernel, and that's an ecosystem on the virtualization side as well. So it's QEMU, KVM, and KubeVirt, which are things that usually my team takes care of, both upstream and downstream. And then, yeah, I've been working. So I was always interested in systems, and I think the best way to deal with different kinds of systems issues is to work on virtualization, because it has all things that you can think of, be it devices, be it CPU, be it interrupts, and so that got me stuck with virtualization for a long time. It has always kept me busy. So, and then besides my work at Red Hat, I also teach at BU, which I skipped this semester, but hopefully next semester I'm going to teach again. And I also work with Red Hat Research. We have a project going on fuzzing QEMU with Boston University that's going well. So yeah.
Cool. So one of the things we always like to run in this show is, sorry, Josh, did you have a question?
No, I didn't actually. Go ahead, Langman.
Okay, sorry. I was just going to say, we always like to ask, like, kind of what brought you into the open source world. And so, David, I was wondering if maybe you could tell us how did you end up here?
Yeah. So I've been on the periphery of open source for a really long time, like back in the 90s. So my dad's office would have old computers, and I would inherit these old computers, and I would need something to run on them. So I would use Linux because that's all I could find. And at the time, I think like you could find Linux in Office stores, like the boxes or whatever.
Yeah.
Yeah. So I might have gotten a few of those, like Mandrake Linux or something like that. But I think I downloaded some,
Come
even
in
though
the
it
back
took.
of a book.
Yeah, it did.
Right.
Yeah. So I would download it. It would probably take me like a week to download an ISO, but I would download it and run it on these whole computers, and I had no idea what I was doing. But that was fun. And then I never really contributed to open source as a result of that, but I was on in the periphery. And after university, so I was using Linux throughout my studies in computer science and things like that. I needed a job, and I had lots of opportunities, but one opportunity kind of stood out, and it was a company called Digium that maintained the Asterisk project, which is a telephony project. It's a PBX.
Oh yeah, yeah, telephony. I can't think of what do they actually call those boxes? The thing that sits in your office is
Sure.
That's it, a PBX.
My phone runs an Asterisk.
Oh really? Yeah. So I did that, and I got to contribute to Asterisk open source project and all more Linux stuff, and it kind of just took off from there. And I've been lucky to contribute to open source the majority of my career at this point. So that's how I got started.
I still remember I had a project a million years ago to basically we were doing an Asterisk implementation to do as part of a backend system, and discovering that you couldn't actually run it in EC2 for a long time. So that was a challenge, but it was actually related to virtualization, which is kind of
it was the timing.
Yeah, I couldn't quite remember why exactly. Yeah, but that was an interesting experience. I still remember also, speaking of old Linux distros, a stack of 3.5-inch floppies that was literally this high, of Slackware, and installing it on a computer and being actually concerned that the monitor was going to light on fire.
Right. We'll get the sync rate wrong and actually destroy the hardware. Yeah, a similar memory to that I have is watching folks download those stacks of floppy disks to acquire Linux on what I think were Macintosh LCs in the computer lab at the time. And it loaded disk after disk after disk to copy them off, take them back to the rooms and do that Linux install.
Nice. All right, so Bandan, on to you. What got you into kind of the open source world?
Yeah, I mean, isn't it amazing? All open source stories are. I mean, my story, I can completely correlate with David, because I can kind of feel like, okay, that's my story as well. Except that it started like a little bit later. I don't think I had access to I didn't even know what open source is in the 90s. And I think the first time during my undergrad days is when I had to make a choice between either buying software that was available from a shady place for a much reduced price compared to going for a version that was available to download online, even though the speeds were they really sucked, is when I started kind of realizing the importance of open source without realizing that that's free or open source software. I remember the first time I was kind of browsing in this marketplace back in India, where you could get software for a much reduced price, and I saw CDs for Red Hat Linux 9, not Red Hat Enterprise Linux 9, but Red Hat Linux 9, and I bought them. I didn't know that I could download them for free, but I just said I have to try these out. So that was my first time I actually kind of tried something which was open source, and I installed them on my desktop only to find that I could either run my network card or my sound card. I cannot run them both at the same time.
Nice.
and that was how I got interested. I looked at this. I was able to look at the sources for Red Hat Linux 9. They were in the CDs, and I did not understand a bit, but it was really. I felt empowered to know that, oh, so this is the code that it kind of runs on the system. That's really cool. But I think the real contribution I made was, believe it or not, it was on Minix. During my when I was doing my master's, we had a project on Minix 3, and I found a bug in the network stack in Minix 3, and so I sent an email to Andy Tannenbaum, and with a patch saying that, okay, this is the change that is required. And he acknowledged it. I mean, I don't know if it got into a release. I didn't know that. There was no easy way to find that out. But the very fact that you could find an issue and can fix it and get it accepted, I think that was what got me kind of interested in the whole process. And the rest is history for me. I had an internship at Red Hat when I was able to work on kernel build tools, followed by working in a hardware company in Massachusetts where we were working on device driver hardening. So that was my real kind of first experience working on, contributing to open source software, Linux based. So I was able to submit patches to drivers, and later on in virtualization. So yeah, here am I.
Nice. That's pretty cool. I like both those stories. I agree, though, Bandan. A lot of them are, I think a lot of the origin stories are often the same. Or the at the very least, it's the I have a scratch and I itched it. Right? Is
for sure. Like in listening to Bandan tell that story, I was thinking. A lot of the reason why I know the command line pretty well is because I had this janky laptop, and for a long time I couldn't configure video drivers. Right, so
that'll do it. Yeah. All right. So talking a little bit more about what is going on in the kind of Kubernetes world. Moving on. So why are you? Or why do you think that kind of virtualization is still important in a containerized world? And feel free, whoever wants to answer that first.
I'll jump in. Containers have to run on something. So what are they going to run on? Of course, you can run on bare metal, but I think that virtualization has it's going to maintain itself as kind of the underlying substrate that containers and applications run on, because they're easy to manage. You can update them easy. They're kind of more flexible than bare metal in that aspect, and they can do kind of interesting things. So you can like overcommit virtual machines on hardware where you can't really overcommit bare metal and bare metal. So as being this kind of substrate that applications live on, I think that it's going to have a really long-lived life within kind of this new ecosystem that's emerging with containers and even what do we call it, serverless and things like that. Those have to run somewhere as well. So where are they going to run? In virtual
I thought it was just in the cloud.
Yeah, exactly.
And serverless.
Well, it's going to move to the background. I think that's what we're seeing with virtual machines. They're moving to the background where maybe right as virtual machines originally started, even when infrastructure as a service originally started, like EC2, we saw people packaging up their applications inside of virtual machines. And so we saw Netflix do that. They used like these image creators to put all their applications into a virtual machine, and then they would just kind of scale out that way. And then we saw that transition to containers. But where was I going with that? I don't think that use case is going to make a whole lot more sense for very long. We are seeing a move away from the applications being packaged inside of the virtual machines, but still they're being run on top of the virtual machines, just in a different way. So it's just kind of a reshuffling.
So David, it's interesting. I heard you use the word flexible in kind of the center of your answer there. VMs is more flexible than real hardware. In an odd way, and I wonder what your thoughts on this would be. In an odd way, I almost think about I agree with that flexibility thing, but then on the other side, if I'm a provider, I often think and answer that question by thinking about how VMs are actually a little bit less flexible for the user, meaning their security parameters and resource allocations and what rights I'm granting on that VM are more configurable. They're more flexible for me if I'm the provider, but I can lock them down in the form I deliver them to users in. I wonder, in a world where we're mostly renting computers from a cloud provider to run our stuff, I mean, do you think that's an important dimension of what like kind of the VM surface needs to provide? Is that ability to like lock VMs down, lock down their resource allocations? When you talk about like overcommitment, kind of touches on that.
Certainly, yeah. So isolation is one of those features that virtual machines provide that containers also provide, but it's a stronger form of isolation. And we're probably going to talk about KubeVirt in a little bit, but I'll just say in KubeVirt we actually have kind of two layers. Well, there's really multiple layers. There's lots of dimensions here. But one of those is the hypervisor itself, which is a really strong form of isolation that we can give people. And then within that, we're also running the hypervisor in namespaces, so kernel namespaces. And then you also have SE Linux, or I forget the Ubuntu equivalent of that. So it's like isolation and security through depth that you're providing when you're using shared resources. And I think the hypervisor is an important part of that, especially when you're renting out shared resources like that, where multiple companies are running on the same hardware. You have no idea what you're running next to. Yeah.
Yeah, is it AppArmor? Is that the
Yes.
AppArmor.
Yeah.
So I was kind of curious about Bandan's. Sorry, our video seemed to have switched on me. I was kind of curious about Bandan. Like, where are you seeing the growth in kind of KVM as a reaction to like Kubernetes and containerization and that kind of thing? Is like what seems to be more of the focus?
In reaction to containers, that's a good question. So KVM is at a pretty low level in the stack. So that kind of makes it immune to. The good thing is we don't have to think about these things because we know that the API on top of us is going to take care of it. So, but that said, when you talk to me about virtualization, I don't think about only KVM. So, I also think about QEMU and libvirt. And so with respect to, how, KVM is going to work with containers, I think there's a lot of kind of emphasis that's been put now that I don't think was in the past is, how can we expose, libvirt APIs that can help with these kind of things. And that was something I don't think used to happen previously. So that's one aspect. When it comes to the real kind of feature that KVM is exposing, which is the hardware isolation that David talked about, the mechanism itself is pretty transparent to containers because they don't really have to talk to KVM directly, and that kind of makes it very, very simple for us not to worry about those kind of things. I think that pretty much sums it up. Yeah.
So just kind of for the audience, what is the difference between QEMU and KVM and libvirt?
Yeah, that's my question was going to be along very similar lines. It's like, could you kind of sketch for us just to give us a foundation for the folks who are listening? Like, where's the line where KVM stops and libvirt starts being the sort of user interface to managing those features, how they fit together? And then likewise, I
right.
like with Chemo as well.
So yeah, I kind of think about, so if you so there's this really popular device drivers, Linux device drivers book. I don't know if they still publish or release new versions, but they talk about mechanisms and policy. So they say that the kernel implements mechanisms and the user space kind of uses those mechanisms to implement policy. And I kind of think of KVM and QEMU in those respects. So KVM is the code in the kernel that enables hardware virtualization. So whatever it is, x86, ARM, and a few other architectures that the Linux kernel supports, KVM is gonna enable hardware virtualization and give us an interface to be able to use them from user space. And that's where QEMU comes into the picture. QEMU is the user space. QEMU talks to the kernel via a device file through a set of ioctls to request services from KVM, which is in this case, all things virtualization, or all things hardware virtualization, that is. QEMU also does, a major part of QEMU actually is also emulated devices. So even though you can pass through devices to the guest, that's not really the norm. I mean, a lot of devices that the guests use are actually just emulated devices that QEMU implements. Or for that matter, in some clouds, it could be some other user space which might not be QEMU. So that's another good thing about this mechanism policy, separation, that you don't have to use QEMU with KVM. You could use your own user space that talks to KVM and gets those services. And then coming to KubeVirt is where we are saying that applications will find it really cumbersome to talk to QEMU directly. So let's build an API on top of it, which will be easier for applications to use. And that's what KubeVirt does, basically. It's a layer on top of QEMU that helps applications to talk to QEMU, which would have been easier. If you were a user, then you probably would have been easier for you to talk to QEMU directly as like a human user, but for an application, it's KubeVirt. That's how I make the distinction between the three.
And actually, that kind of leads to my. Oh, go ahead. Sorry.
Just a quick clarifying point on that, because of it, you mentioned a couple of times of wherever there is hardware virtualization support, like with VTX on Intel. Is there or was there historically any support in KVM for virtualization on architectures without that hardware support? Like I remember some of the techniques in Zen for plain old x86 who didn't have VTX. And they're elaborate and like you wouldn't want to have to use them, but they're fascinating sort of from an implementation point of view. Was there ever any non-hardware virtualization that KVM could do?
That's a good question. So when it comes to the real hardware extensions that implement virtualization, no, the answer is no. That said, KVM is really a hybrid model where it takes ideas from Zen as well. So KVM actually came into being after hardware virtualizations were introduced by Intel and AMD. So that's the first part. That said, we do have a lot of para-virtualized interfaces, for example, which is obviously brought from Zen. So for example, timekeeping is one of those things. So one of the things KVM does is, share this, it has this shared space between the guest and KVM through which we are able to timekeep, use timekeeping features. The guest is able to kind of get accurate timing without having to perform a set of, severe penalty that you would have if you had an emulated device.
Right.
That said, the other thing is, in the initial days of virtualization, hardware extensions had a lot of limitations in what kind of instructions they can execute in what processor mode. So for example, in real mode, processor was not able to execute certain instructions when you were running in a guest. So KVM would emulate them. So it's a mix of all these things together. And my answer to you would be, it's yes and no both. It's no because, yeah, we had never had KVM when hardware virtualization did not exist. But now, even though there is hardware virtualization, but KVM also does a little bit of emulation that you would expect from a traditional kind of an old hypervisor like Zen.
Right on.
That's crazy. All right, so kind of moving on into kind of talking about KubeVirt. So like, where does that relationship live? does KubeVirt use QEMU? Does it use KVM? Does it use libvirt? Does it use all of the above? Where does KubeVirt and kind of, one of those tools kind of, where does that line drawn? And does that line stay still? Does it move around? Does it matter?
Yeah. So KubeVirt is really just a fancy wrapper around all of this. We are using libvirt, we're using QEMU, we're using KVM. We didn't necessarily need to use libvirt. We chose to because it gave us some. It allowed us to rapidly iterate on this stuff quickly because libvirt gives us a really nice interface, like a user interface, CLI interface, but an interface to manage the lifecycle of virtual machines that we would have had to create ourselves. But at the end of the day, we're using QEMU KVM really, and we are a wrapper around this. We're launching what's essentially just a QEMU KVM process in a container, well, in a pod, in a Kubernetes pod. And KubeVirt itself is just a set of controllers to manage the lifecycle of that pod, and also to provide that pod the kinds of resources, cluster resources that it needs. And so if we're talking about like CPU and memory, we're using the Kubernetes scheduler to provide those resources to the pod, and then we have the kind of a small glue layer that's passing that on to the KVM process. Same thing with storage and network. We're using the regular pod network, being an IP address, and we're have the glue in that pod to give that IP to the virtual machine. Same thing with persistent storage. You're giving it a persistent store PVC to that pod. You're attaching a PVC to the pod, and then all of a sudden you have a boot image for your virtual machine. So KubeVirt is just layers and controllers around this kind of underlying technology.
And actually, I mean, so for me, that brings up a big question, which is like, when I think about a container or by extension a pod, right? Because a pod in a lot of ways acts a lot like a container. Like a virtualized machine expects a lot of things, like it expects all the ports to work, right? It expects certain kinds of storage. It expects I guess I'm thinking about networking. But so how does KubeVirt or wherever, right, like some tool chain, how does it kind of tell the virtualized OS, right, that, oh no, you're not running in a pod, you're running just like you normally would, because I presume you kind of masquerade to it so that it doesn't, you don't have to kind of change the inside of the virtualized machine. Does that
Sure.
make sense?
Yeah, I kind of get what you're getting at. So when we launched the KVM virtual machine, the environment that it's in looks very natural to it. You're going to have like QEMU is going to see the KVM device. It's going to see things like the IP address and the and persistent storage. All kind of just look like mounts or interfaces within that environment. It looks like you're just running on normal, like in a normal non-containerized environment. So we've done a lot to kind of make it appear that way, and that's where I talk about the glue. So we actually reach into that pod with a privileged daemon set to kind of set things up for us in a way that mimics what you would expect. So that when we actually launch the virtual machine using ultimately libvirt to call QEMU KVM, it just looks normal to it. It doesn't think anything different. So we've recreated that environment for the virtual machine.
That was kind of what I was expecting, I guess. So are there trade-off or are there negatives to that? Like, I mean, part of why, like I said, I go back to networking a lot, but part of why that networking works the way it does is to kind of minimize the resource consumption and provide some level of, or different kinds of security. And so are there negative sides to kind of pretending that the virtualization or the virtualized OS is running in a normal, kind of, virtualization environment, or are you dealing with those negatives on the outside? So kind of like, you set it all up so it feels like it's a normal environment, but when it tries to get out again or whatever, that's where you bring back, that density or security or whatever those trade-offs might be.
would say there's necessarily negatives. It's just it's different. So, like if you had complete control over a bare metal machine, you're running libvirt on it. You could create your own bridge interface and your own network and do whatever you want. Here we are. You could say we're limited by the types of networks that we provide to the virtual machine, but really we're not. So we have it's just at a different layer. So at the cluster layer, we can create multiple interfaces and pass multiple interfaces to pods today using Multis. And we can provide like SRRV devices and things like that. So we can do a lot of the same things that we could do if we were in complete control over a bare metal machine, but we're doing it at the cluster level using Kubernetes like APIs to kind of manipulate those sorts of things and assign them to the virtual machine pods. So it's really just a shift of how we look at these things. It's still flexible, but just in a different way. So we still have that kind of control, but it's different looking.
I gotcha.
Right on.
That makes sense.
So David, I'm curious, kind of at an implementation detail level, to maybe help me understand that interface and where KVM infrastructure ends and KubeVirt wrapper begins, right? Like, where is that line and what's that interface look like? Sorry, I kind of lost my train of thought there. You talked about a set of custom controllers managing resources for these pods that we're going to launch VMs into. Do those custom controllers manage a set of CRDs, and is there a custom set of API endpoints represented in those CRDs for managing, communicating with, and monitoring the set of VMs that we're running in that cluster? Like, what's the implementation of that actually look like?
Yeah, exactly. So we have our own API. And if you look at our API, you wouldn't know that it's necessarily KVM or QEMU or libvirt behind the scenes. We have, maybe if you're really knowledgeable of what's going on behind the scenes, you might see certain values that make sense only for KVM and things like that. But our API is unique for KubeVirt. You have a virtual machine API that describes, how to create a virtual machine and things like that. And we have two layers of controllers. So we have a control plane that's living at kind of the cluster level, and it's managing the lifecycle of virtual machines at the cluster level. So when you post your virtual machine to the Kubernetes cluster, these cluster level controllers are going to say, hey, I see a new virtual machine. I'm going to create a pod for it to live in. That pod's going to get scheduled onto a node somewhere with the correct resources assigned to it. So the right amount of CPU and memory that you've requested there. And then we have a daemon set, a privileged daemon set that's going to live on every single one of our nodes. It's going to see when that virtual machine's pod gets scheduled there. It's going to see that pod come up. It's going to reach into that pod, and it's going to manipulate some things. So it's going to be the thing that's helping facilitate network and some of our other things around persistent storage and stuff like that. And then within that pod itself, we have a really small daemon set that's just kind of gluing all those things together. So the things that the privileged daemon set went and set up for us, our shim process inside the pod itself is going to see those things and construct the libvirt domain XML, and ultimately pass that libvirt domain XML to libvirt and actually start the QEMU process. And then the result is, because of this whole chain of operations and controllers, you have a virtual machine that starts in a pod that really, it kind of behaves like a pod in some ways too, because the virtual machine can talk to all their pods and all their virtual machines, and you kind of just have a virtual machine all of a sudden appearing within this cluster, and it looks like just a native application within there. So hopefully that answers your question. Yeah, there's a lot involved and multiple layers to get to the point of actually starting the virtual machine, and Kubernetes is kind of coordinating the lifecycle and kind of the management and resource placement of all that.
Right on. So, one quick follow up to that, and this is also sort of for you as well, Bandan, and it is, if I'm working with KubeVirt, am I working with nested virtualization a lot because somebody's running the cluster on a VM in the first place and then trying to do KubeVirt things? Is that a use case that's ruled out prima facie, and we don't ever do that? Like, how often does that come up? I'm just like, it just immediately popped in my head. I'm not like, every cluster I ever touch is running in a VM in the first place. So what does it look like if I then want to run KubeVirt on those clusters?
Yeah. So we definitely support, from a community standpoint, nested virtualization and use it every single day. That's what my dev environment is. We see people using it in production on infrastructure as a service because they can manage their virtual machines in really unique ways and provide levels of uptime guarantees that are difficult even with like EC2. So with KubeVirt, you can live migrate your virtual machines, so you don't lose them and things like that. And that's nested virtualization. There's limitations to what you can do with that, and it's complicated, and you can hit some really crazy issues with that. But it's definitely something that the community uses. It's not something Red Hat supports right now in their OpenShift virtualization product, but it's certainly a really strong use case within the community.
Yeah, so I had a question for David. So you mentioned this certain, level of generalization, if I understood it correct, and the API. So is it true that there are people use something else other than libvirt, or is that do you know of cases where libvirt is not in the picture at all?
Not for KubeVirt today. So KubeVirt does have libvirt in the picture. It was designed in a way to isolate the usage of libvirt and really even KVM to that container, so the pod that's actually running the virtual machine itself. And the API we were trying to design it agnostic of what that underlying technology was. At this point, it's so ingrained into our design that I'd be really surprised if libvirt, KVM were ever replaced or swapped out. But we have the potential to do something like that in the future if
Yeah.
we needed to.
Yeah. And on the nested virtualization aspect, I wanted to add that for a long time, after nested virtualization came into being, I mean the best use case that we could think of was testing, and which is running a guest inside a guest and making sure we are able to expose features. Or for example, as you said, we don't have a bare metal system in hand, so we want to set up, even though I would say that nested virt and first level virtualization are not really the same in terms of so a bug that reproduces on nested virt necessarily does not mean that bug is gonna reproduce
Right.
on our bare metal system with virtualization. But this whole new thing with newer use cases that are coming up, they're very interesting because they are stressing nested virtualization in unique ways. And I mean, one of the things that I have personal experience with is we are able to find new and interesting bugs that we had never found out before, and they are not reproducible on bare metal or just through regular virtualization. In fact, recently we found a hardware bug which was only reproducible because of the nested virtualization setup. And so I think that's kind of the good thing of the whole nested virtualization getting introduced into the picture. And yeah, it's interesting.
Right, because there is, I mean, in a sense, or at least in a subdivided sense, you are exercising different hardware when running nested virt, right? You got the second level address translator, and like some of that's implemented in PMMU, correct? So if I never run nested virt, I never touch that bit of hardware inside my CPU, right? So yeah.
I always love new and interesting bugs. So kind of moving on a little bit. So what's the future, do you think, of the kind of virtualization within Kubernetes? When we were thinking about the setup for the show, right? Like the obvious answer for virtualization in Kubernetes is lift and shift, right? So I have a running application. I want to be able to manage it on the same control plane as I'm running everything else. Okay, let me copy that virtual machine over, and then I'm done. Eventually, that'll end, or it may not be the best choice for all applications. So what's the plan? Where we're going to be in 10 years? I don't know, 5 years, 2 years, who knows?
So there's a story arc here. Lift and shift.
And it tends towards unikernels, right, David?
I don't know. Traditional Virt is what we're talking about with lift and shift. And so you would take an application that's maybe it's a legacy application, and you want to transition to like a containerized or cloud native, I don't know, whatever this buzzword is, like infrastructure. So you want to move to Kubernetes, but you want to bring your virtual machine with you. Great. So KubeVirt allows that. And I think that was the thing that kind of justified us building this to begin with. And we needed that. But that's not the full vision. So that's the thing that lets us do the thing we want to do. And that's where we're seeing a lot of traction, at least initially. And I think we're still kind of at maybe the first part of the adoption curve for KubeVirt, and that's what people are using it for. The next step, I think, is using KubeVirt as infrastructure as a service. So having the same sorts of patterns that you would see in something like EC2 or Azure or GCP. And we're getting there on the development side where we kind of have that at this point. It's not necessarily adopted by users quite yet, but that's where we
and so
where we are. Yeah.
Just to help me understand, to interrupt briefly to help me understand kind of what that means. That's sort of I want to do Terraform kind of things, but I want to write Kubernetes style YAML because I've got an investment in the tooling and I know the terms of and the way the API works. And is that kind of the idea?
You can think of it like that. There's a set of operational patterns that we see in infrastructure as a service. So if you look at like EC2, we see auto-scaling groups. And what people are doing with these auto-scale groups is they have lots and lots of virtual machines. They're scaling horizontally. And instead of, it goes back to the whole pets versus cattle analogy. When something goes wrong with a virtual machine in their auto-scale group, they don't care like what actually happened. Nobody's going to look at it. Somebody or something, automation, is just going to kill that virtual machine, and no one's going to spin up to replace it. So that's what I mean. Infrastructure as a service like patterns. We're introducing those into KubeVirt. We have that today, and then once we have that, which we do, the next thing we are working on is for ultimately KubeVirt to be the substrate to run more Kubernetes clusters on. So now we have an ecosystem where traditionally you would have used like VMware on bare metal and run Kubernetes cluster on top of that. Now we have pure Kubernetes. So you have Kubernetes at the bare metal level running KubeVirt to launch your tenant clusters on KubeVirt virtual machines. And I'm working on that right now. That's the kind of the next step. And then the future step, the one that I don't really quite understand that's on the horizon, is ultimately I think that KubeVirt is going to be the heart of multi-cluster in a certain way, because it's the substrate that you can actually run multi-cluster on. So if you're looking at a new project like KCP, which go look it up if you're not familiar with it, but it has the potential to like launch clusters on demand for your workload. So if you have a workload and the cluster doesn't exist for it, and infrastructure doesn't exist for it yet, then perhaps we can have smart controllers that can spin up infrastructure on the fly for this application to live in and things like that. And I think Kubernetes or KubeVirt has potential to be the thing that's powering that for bare metal. It doesn't necessarily make sense for public cloud infrastructure. Maybe it does. I don't know. But when we're trying to replicate those sorts of things on bare metal, that's where KubeVirt would be. So there's a long tail here, I think, for KubeVirt. And the thing that kind of justified us making KubeVirt, so that traditional virtual machine use case, that's the thing that got our foot in the door. And I think the potential is much greater than that. But it'll be behind the scenes. People won't know that they're running a KubeVirt. It's there. Yeah.
So can you repeat what project was that? Did you say ACP?
KCP.
KCP.
Yes.
Oh,
Yes.
okay. That's
Kubernetes
the stuff.
control.
That's literally the project we talked about with Clayton, and I think.
Yes. Yep.
So turtles all the way down is what you're telling me.
That's exactly what I'm saying. Yep.
So that's really interesting, particularly the part where you get if you have really sophisticated live migration, right? You can then you can have, you can actually kind of realize that dream, right? Where you can kind of say, oh, you know what, I need that new Kubernetes cluster, or I need this Kubernetes cluster to be over there, for performance reasons or whatever. And you can actually live migrate the entire cluster to, wherever it's 9 a.m. so that you can handle all those logins or whatever. Right?
You could do really crazy stuff. So certainly live migration is interesting for lots of different reasons, because it allows us to, live migration allows us to do like an update of the underlying cluster without impacting all the clusters that live on top of it, which is great. So you're shuffling around virtual machines or running Kubernetes clusters as you're updating the nodes that are underneath it. That's great. But another thing that's interesting is we can start thinking about suspend and resume of clusters. So you have like clusters that you spin up, and maybe you've already created a quorum and everything within them. And then when you don't need it, rather than tearing down the persistent part of that, you just kind of suspend it, give all those resources back to the underlying clusters. And when you need it again, it just kind of starts up again, and it's right where it was. So there's lots of just really advanced future-looking things we can do here.
So that was actually, I was kind of like had a related question in the back of my mind for a little bit there. Is that, but that brings it up well. Is that virtualization in general is slow to start. At least compared to a container. Is that an issue, or is it more of the way I've dealt with it in systems that I've built, right, is that I just account for, hey, I need a minute to start this thing over here. So that means if I'm going to do, if I don't want to ever be cold, I ever want to be out or whatever, I just start the thing, right, and make sure there's a minute in there, and then, and then bring the other one down. Whereas with containers, I can kind of do it more instantly, which on paper, it's kind of like, there's a lot of features that get written up by the tech rags that a lot of the time I'm not really sure I care about as much as the tech rags give it some reason to write about something. And that's one of the things that I always wonder about is like, but is there a performance issue there where you need to be able to start the virtualized environment more quickly? Is that something that needs to be addressed so that you can do some of this magic that you're describing over time?
We like to limit. So there's I can say that like latency. So the amount of time you ask for something before it actually comes available. And when we look at auto scaling, so if you're trying to auto scale your application and under the scenes, we're trying to provision infrastructure to meet that demand, then the quicker we can do that, the better. So the idea of like pre-warming could play a role. Just things within the guest itself. So we saw a huge improvement back in like I forget what it was, whenever like System D came around, when you started having just the boot order in parallel rather than sequential, that improved boot times quite a bit. I think ideally anything under a minute is probably good enough for most people when we're talking about spinning up infrastructure. When it gets to like 5 minutes and things like that, then you're probably looking to optimize. Infrastructure as a service, when we look at like EC2, they take a while to start up your EC2 instances.
Try CloudFormation.
Yeah. Right. So
40 minutes later.
I think we're faster than that, hopefully. But it all depends on the environment. Yeah, it matters. That's the short answer.
Right, but I guess it matters, but it's kind of like there's a threshold where it matters, right? There's kind of like almost like a step function, right? If it's under a minute or something, maybe it's fine. But then there's planning around it, or planning, right? So like you have to build into the tool some level of planning around it, so that it can kind of tolerate that outage. I guess for me, in my development experience, I need to tolerate when something goes away anyway, and I'm not sure how spin up time is different than going away. So it's kind of like, I feel like that's one of those things that I'm building it into my system anyway. What difference does it make? But I was just kind of curious on your take. Josh, did you have a follow-up to that?
Well, I was just kind of wondering, like, it is a follow-up to that question, really. Like, so Langdon was just asking David Bandan about a number of concerns specific to this use case and this kind of driving infrastructure as a service with KubeVirt. When you're working on KVM and QEMU, having a really hard time saying that this morning for some reason. Nevertheless, are these things, are these two teams and you two folks communicative about these issues, or is that orientation you described before of mechanism rather than policy at the KVM layer mean that you necessarily stay loosely coupled from sort of what concerns are this project that's using KVM, what does it have versus other ones? Like, are KVM folks specifically thinking about these KubeVirt and Kubernetes use cases and in communication with that team? Like, does that interface exist at a team level, or do we restrict it to software precisely to make sure the coupling isn't too tight and that one is concerned with policy and the other concerned with mechanism?
Yeah, I don't think it's very, very tight at this point. And whether it's going to be any advantage, I don't know. We probably will. But that said, yeah, I mean, there are people who focus on these aspects even in the virtualization group. So there are people who spend a lot of time understanding containers, working on them. It's just the nature of KVM work. Probably it's not conventional to think about containers. But that said, when you guys were talking about this question, this interesting question that Langdon brought up, and Langdon asked me something similar a while back, and I said, well, yeah, we don't think about that. But yeah, it really depends. Sometimes we do, because for example, boot up times that's a interesting topic that comes up once in a while, and there has been changes in QEMU to actually improve boot up times. Like, for example, let's not get a traditional chipset emulated. Let's not emulate a traditional chipset. Rather, boot up something that is like just takes the shortest amount of time possible.
Right.
Not initialize a lot of emulated devices. So we do get into those only, but it's not part of the. I don't know. I don't think it's part of the like a process as such right now, but it's kind of increasing. It's becoming more and more frequent and common.
Right on. And then my next question is it is not so much a follow-up on that, but is more a free skate, let's call it. I'm just going to say to both of you, AR64. And what that really means is, can I use any of this stuff outside of the Intel architecture? What does that look like? Are there teams working on ARM servers? I know KVM runs there, so what's the KubeVirt picture look like for the future on architectures?
I can speak for KubeVirt. Yeah, we have community members that already run on ARM, so we support it from a community. There's multiple layers here. So we have ARM at the the controller layer. So if we're going to run on ARM infrastructure, we probably need to build our controllers, even the cluster level controllers, to run ARM. And then we have like the underlying, like the nodes that the virtual machines run on. We need to have all of our controllers that are at the node level to be ARM as well. But then there's this complex use case where we have containers that might need x86 for the control plane, and then we might have different types of nodes within our cluster, some x86, some ARM, and that's where things get really complicated that we don't do really quite well yet. Being able to schedule things accurately to the right architecture and then have the right components on there that are built with the right architecture. But we're looking at things like that as well. Yeah.
So related to that, do either of you, Bandan and David, do either of you see yourselves, maybe not you, but like your teams, right, making direct requests of CPU manufacturers, where like to Bandan's comment made me think of this. Is like there's a lot of junk on that chip that you don't care about, and so if there's a way where AR64 knocked out half of its calls, blanking on the right word, but like, would that be better? And is there a way, does that say is something that you see going forward, that there's actually specialized chips for this kind of scenario?
So is it? I don't know the answer to that. All I can say is I have experience with x86, and the turnaround time to listen back from hardware manufacturers is really, really long. So by the time you get back to hear from them, the ship has sailed. So I don't know how advantageous would that be. That said, I think ARM traditionally has been kind of working more in sync with software providers, listening to their requests, just because of the nature of how ARM works. And maybe it's a possibility, yeah. But honestly, yeah, I don't have an inside or good experience, that I can share with you right now. That okay, yeah, that's a good idea to talk to hardware folks.
Well, so then that kind of, David, unless you have something to add to that, because it makes me jump to what I see as the analogous question on the software side, which is, are we going to run other systems than Linux? Are we going to run unikernels above Linux virtualization? How much call for that? Do you hear people doing that in the community? Is this a really popular idea? Is this stupid and crazy? We've got a good networking stack in Linux. Why do I want to run a kernel that's built just around my application? Like, is that a use case that's important for the KubeVirt stuff?
It comes up. I don't have a lot of experience with it, so I think some people are even doing this already with KubeVirt. I don't know their use case and why. My instinct is that it's kind of a niche use case, but I could be totally wrong, and it's something that I don't understand well enough to really speak to. But I know that it's something that exists within our ecosystem today.
Yeah, it's one of those like unikernels. Like, I'm kind of on both sides of the fence there. There's a lot. It makes a lot of sense, right, to use like an x86 chip, because it's standardized and it's got a general use case and all this other stuff, right? But then there's also, hey, I built this chip specifically for this particular scenario. And so you kind of have the same idea, right, with Linux and like a unikernel, right, is that I have kind of this general purpose thing, and it does quite a good job at a large number of things, but then there's also a small piece, that maybe, it could be focused on. So if you're running a golden image kind of world, right, anyway, so we're building a virtual machine, and then we're putting, golden copies of it out, or taking a golden copy and putting out instances, which is kind of the containerization idea as well. Maybe something like unikernels makes sense. The problem I see is that the unikernel doesn't get exercised anywhere near as well as the general purpose solution. So at least for me, I have yet to see, there's a lot of good research in the unikernel space, but I have yet to see in the unikernel space kind of a good reason that offsets the fact that it's not getting it exercised as well, and that you have to kind of go through these extra steps. But I don't know. That's just my 2 cents. It's kind of like, So that's a nice, easy closing question. I did want to ask quickly though to David. I noticed your website redirects to a music album, and I just wanted to ask what that was, because I didn't actually listen to it.
Oh, interesting. Yeah, I guess that's still my GitHub. So that used to, that's kind of funny. That used to be my resume, and now it is me playing goofy banjo music. And that is about the all there is to that story. Yeah.
That's pretty hilarious. So I was looking for your Twitter handle for a tweet, and
it does not exist. There is no Twitter handle. There's
Right.
no social media. GitHub is about as far as I get.
Well, now it means, if you're doing the music thing, though, you can just start a TikTok, and you can and start there.
I'm scared of TikTok. Somehow I don't have TikTok, but I feel like they already know everything about me. I don't even know.
I feel this exact same way. I have the exact same feelings about TikTok. I'm not even on there, but I'm afraid of their surveillance somehow.
Right. My nephews are on there, and somehow they know that they're my nephews, and that somehow correlates to me.
Well, David, you found the leak. The question now is how to plug the leak.
So I will say we actually had a pretty good question in the chat, but we are out of time, and so in the interest of saving time, we will not answer it. But basically, is that should Kube/OpenShift be following the Linux model of do one thing well rather than do all the things? And what I will propose is that we will try to bring that up on the next episode with our next guests. And we will let you off the hook because we know our guests have already planned to do other things today. Excuse me, and so we'll wrap up there. But thank you so much, David and Bandan, for joining us on the show. Thank you to the guests, or to the audience, I'm sorry. And we really hope to see you next time. We are the last Tuesday of the month, and we have a whole bunch of great guests lined up. Check out our website at cubebyexample.com if you want to see more about the show, watch past episodes, or see and see our kind of upcoming guest list. And we'll see you next time. Thanks y'all.
To both of you.
Thanks for having me.
Bye.
Bye.